Okay, so let's start. Hello guys, welcome to today's Dapp Learning sharing sessions. I'm Alex, the host for this session. So before we start, please allow me to introduce the Dapp Learnings. And by the way, I'm also the member of this community. So Dapp Learning, our main tutorial is located on the GitHub, and our purpose is to give the junior developers an executable and simplest blockchain Dapp learning tutorial, and present advanced developers with a platform for communication and cooperation. So today we invite Guru from Codex, and today's topic is Censorship resident storage network powered by the Decentralized Durability Engine. So now let's welcome to Guru. You have the microphone.
Hey guys, I'm quickly gonna share my screen.
Okay.
Yeah, before we jump into the slides, I'll take a moment to just tell about what we do at IFT. So IFT is Institute of Free Technology, and I've been contributing to IFT for the last 2.5 years. So we have a portfolio of multiple projects, starting with Logos, which is basically a network state building and moment building side of IFT. And we also have other projects on the technical side like Waku, which is a communications protocol. This is very much similar to Ethereum's Whisper. So Whisper was a part of Ethereum white paper itself, and Waku is pretty much the same protocol. I'm sure you've heard about it from Vitalik tweeting about Waku multiple times over the year. So yeah, it's being used by Status, Railgun, Graph, and multiple other projects under the hood. So yeah, this is the communication side of thing. And we also have Codex, which I'll be talking about today. And this is the storage side of Logos, where you can pretty much store a file on Codex in a decentralized storage network and build applications on top of this, leveraging decentralized storage as well. And another thing that I would like to highlight is Codex is kind of new to the market compared to the existing DSNs. So it's kind of early, and it's a great time for you to start contributing to Codex if you want to. But I'll be taking you through about Codex in the next couple of minutes. But you can also check out our other projects in the portfolio at this website. It's free.technology, and you can find this portfolio over there. And if you're looking for a job, we also have a job board over here if you are interested in looking for a position. But going on with Codex, I have a short presentation before we head into the hands-on part of today. So when we look at the problems that exist with centralized storage solutions in the market right now, I would like to categorize it into 6 of these problems, the major ones. The first one is data breaches. For example, if you store something on a centralized storage service like AWS or any kind of cloud-based storage, this is very much vulnerable to data breaches because it's a single point of storage, and also the access control usually lies with the storage providers itself. So you can't really trust them on the security side of things. And data integrity is also a problem. And this is directly linked to things like immutability. So if a storage provider wants to kind of modify your data, they can just do it because they have physical access to the single point of failure network or the place where you've stored the file. So that's another problem. And there's very limited transparency about what is happening in the storage infrastructure. And this leads to multiple other problems, which include censorship, where people can basically censor data based on the source of the data because the source is from a single point. So censorship is a problem in multiple cases. And when you use cloud-based storage, it's also custodial to third parties, which means the access control, the liability, and everything remains with the person who's storing it and not with the person who wants to store it. So this ultimately removes the powers from your users, leading to various other data silos and privacy problems. So this is a a very high level discussion on uh, how the current centralized storage systems are not reliable enough. And uh, again, like I mentioned, it's single point of failure, users' privacy is under third-party custody, and it's also there's no verifiability. So this makes the whole system easy to tamper. And if you are asking us why Codex is intending to solve this problem and how it is intending to solve this problem, we have 6 main value propositions again. So the first point is decentralized. Codex itself is a decentralized storage network. So any file that you store on Codex is going to be stored on multiple nodes in the network rather than just one point of contact. So the second point is censorship resistance. Since the file is stored in multiple nodes, this ultimately makes us censorship resistant so that a particular organization or a region cannot censor you based on a particular parameter. And Codex is also durable. This is what makes Codex different from the existing alternatives in the Web3 space. There's already a lot of alternatives like Filecoin, StoreJ, Arweave, and a lot of other projects who are trying to build a DSN. But the point that makes Codex different from the existing DSNs is durability, and I'll be talking more about it. And again, it's accessible. Any file that you store on Codex is going to be perpetually available over time. So you can access the file at any point of time until you have it in the storage contract. Codex is scalable. It can scale to multiple sizes of storage. You can easily store files worth DBs using Codex. And it's also cost effective. That's the most important value proposition. It is very competitive to the Web3 storage pricing standards, and cost effectiveness is something that we've been thinking of from day one. Now, looking at the definition of durability, we have multiple factors that contribute to this one word, umbrella word called durability. And some of the factors here are redundancy, which makes sure that the file is stored in multiple nodes, and persistence, which makes sure that the file is available or is persistent for a particular period of time, and incentives, which make which kind of make the node operators join the Codex network and contribute to the network by offering storage. There's also availability of the file, integrity of the file. So there's so many reasons around this one word durability. And to know more about this, the best resource that I can point to is the Codex white paper, which I will be linking in the end of this slide. So just a quick nutshell about how Codex is different. Other DSNs compromise either performance or durability for the sake of providing you a good experience. But with Codex, we're trying to solve both of it parallelly. And in a nutshell, if you want to understand Codex, the Codex architecture, this is how it can potentially look like. So there's a storage network layer, marketplace layer, and a peer-to-peer file transfer layer. So the storage network layer has storage providers, which are the ones in blue, and storage renters, which are the ones in yellow. So there's something called Decentralized Durability Engine, which kind of orchestrates the whole process and makes the storage network reliable with Codex. And when we look at the marketplace layer, this is where we have storage contracts deployed on the blockchain. And these storage contracts make sure that the incentivization happens for every node operator who stores your file, and also verifies if a particular file is available over time. So that's the second layer. And finally, we have the peer-to-peer file transfer layer. And we have a distributed hash table for this. And yes, we will be diving deeper into the architecture in the next few minutes. So looking at the storage marketplace, I just wanted to give you a visual overview of how the storage deals happen in Codex. So there are multiple storage providers who are the ones in blue over here, and there are multiple nodes who wish to store data. So these are the consumer applications or any kind of node that wants to store some data in Codex in exchange of some kind of monetary benefit. And we also have a blockchain. So the blockchain is the marketplace layer, like I mentioned before. And over here, we have original data from the person who wants to store the file. And when you deploy a store, when you interact with the storage contract, what happens is we generate the parity data, and a storage contract is created, and the person who wants to store data basically funds the storage contract, which is on the blockchain. And the other storage providers who wish to store the file in exchange of monetary incentives store the file in their nodes by downloading the data, and then basically the parity and the original bits move over here, and there's a verification process that makes sure that the file is stored over a particular period of time. And every time the verification happens, a proof is generated, and the proof of storage is submitted to the blockchain. And this way, we know that at periodic intervals, when this verification happens, we know that the particular node is storing file for a particular amount of time. And finally, after the storage contract is done, the payment is received by the storage providers, and the collateral is returned. So the storage providers are also asked to provide a collateral before they can do this. And we do have a tokenomic section in the light paper and as well as the white paper. So this gives you a deeper dive into how these things work. But this is a very, very high level overview of how the storage marketplace functions. If you don't have idea about how storage marketplaces work in Web3. So this is a very high level overview. But yeah, this is the link to the Codex white paper. You can scan the QR code to access it. I'll also give you some links later in the end of the session. But the next part is joining the testnet. So Codex is available as a testnet right now for users to build on top of Codex and also experiment Codex. And to do this, you can join the Codex Discord server. And we have something called a Codex node setup category in the Discord. And over here, you can just go to the step 1 channel and then follow all the instructions over there. And by the end of the 6 steps, you will have your own Codex node running. And this shouldn't take you more than 5 minutes. So it's kind of easy. And I'm also going to walk you through live after this. That's the next part of the session, where we will be running a Codex node and interacting with the node. So let's go ahead and do that. So I'm going to use the Codex docs as a reference for doing this. You can head on to docs.codex.storage. And by the way, if you have any questions, I can also help you out asynchronously on Discord, or you can also ask your questions in the Google Meet itself. And I'll try to answer the questions in the end of the session. So yeah, you can go to docs.codex.storage to find the documentation. Or alternatively, you also have the Codex cheat sheet, which I shared previously. So yeah, you can use either of these resources. They are basically the same. But now let's go ahead with documentation. Once you go here, you can go to join Codex testnet. You can just go here to the top. There's something called setup Codex with installer. This is the recommended way to use Codex. And this also helps us with some data for basically to understand where people go wrong and to make the Codex experience better. So you can go ahead over here. You can read the disclaimer about what data we collect and how it is being used. And yeah, once you agree to the disclaimer, you can go to the second step, which is the requirements. And the requirements over here are basically just Git and NPM. You just need both of these things set up on your machine, and you'll be able to run the Codex node. But another important blocker for people who are in public networks is the port forwarding setup. For example, if you are in a public network like me, I'm on a public network right now, so I won't be able to modify the ports or forward the ports at this point. But then you can still run a Codex node without port forwarding. It's just that you can't upload files because the discovery port will not be working along with the transport port unless you forward them. But you can still go ahead and do these instructions in this next page. If you don't wish to provide any data for the Codex installer, you can also set up Codex manually by using these instructions. This is going to take a bit of a time because this is going to walk you through every command step by step. But over here, we have a easy installer which can get you a Codex node up and running in a few minutes. So let's go ahead with the installer now. So the third page has a video tutorial as well if you wish to watch it later. But going down, we have this particular command called npx codex storage. This is all we have to run for having our node up and running. So just copy the command and open a new terminal. I'm going to do it from the beginning. So open a new terminal. And once you have the terminal, let me make it a bit bigger. Yeah, once you have the terminal, you can just hit npx codex storage or just paste it. And once you run this, you should be seeing this particular interface on your GUI. So yeah, you can go ahead with step 1, which is downloading and installing Codex. You can use your arrow keys to navigate around these steps. But yeah, the first step is to download and install. And once you hit enter, this should take a few seconds to get your Codex binaries installed in your machine. In my case, I already have it installed. So yeah, it just tells me that I've installed it already. And once you do this, go back to the main menu. And you can go ahead with the second step, which is to run a Codex node. And yeah, again, in my case, I have a Codex node running already in my machine. So in your case, this should ask you for your ports, the ports that you entered over here, the discovery and transport ports, which by default is 8090 and 8070. You can just hit enter over here if you don't wish to if you don't wish to modify the default ports. And yeah, it should be very much similar to this. You will have these two questions, and after you answer them, you will have a Codex node up and running. And after that, you have an option to couple your node along with a ERC20 wallet address, just so that we know who is running the node. So you can simply drop your Ethereum address over here if you wish to. This is completely optional. This is just to know who are our early stage contributors who wish to run our node. So yeah, this is completely optional. But if you do that, you can couple your ERC20 address with the node. And after that, you can also get the altruistic mode on the Codex Discord. We have a separate role on our Discord called the altruistic mode. And this role is given to people who help us stock food Codex in the initial stages. So you can basically get it, and I'll tell you how to do that. And to do that, you can go to the main menu again, and you can go to the third option, which is check Codex status, check node status. And yeah, ideally you should be seeing something like this. Node is online, but has few peers, or node is online with many peers. But if you have a message saying node is offline, you'll have to drop a message on Discord, and we'll help you troubleshoot the whole process. And yeah, now that we have the node online, we can go ahead and view the node information. So you can see it on the second option, which is over here. So you have this node ID right over here. Just copy it, go to the Codex Discord and paste it on the in the pod channel with the /node command. I can quickly show you how to do that. So when you come over here, where's my bot channel? Yeah, over here. So over here, you can just type /node and drop your node ID. In my case, I already have a node associated with my Discord account, but in your case, it should say the node is coupled with your ERC20 address and your Discord account. And to verify this, you can also go to metrics.testnet.codex.storage. And over here, you can see your active nodes. And if you click on a particular node, you can see that the node is linked to a Discord. And you can also link it to your ERC20 wallet address. So this is basically all you have to do to run your own Codex node within a matter of few minutes. And you also have more options in the main menu to edit your Codex configuration. So the default paths are over here. If you want to change your Codex node's location in your machine, you can simply edit it over here.
Hi, Guru.
Oh, sorry.
Can I ask a question?
Yeah, sure.
What we currently run is just a P2P network or blockchain network?
So currently, Codex is in altruistic mode, which means that you can't really, you can still interact with the marketplace contracts, but it's not integrated in the Codex installer yet. So right now, we are just running the peer-to-peer network, which kind of lets you, share files with multiple other nodes.
Yeah, if I want to use the marketplace, so what blockchain will you use? Like Arbitrum or Optimism?
Right now, the Codex network is in testnet. So we just have all the contracts deployed on Ethereum Sepolia testnet. But eventually, we don't have a choice as of now for which blockchain we are going to use. It could also be multiple blockchains, but ideally, it should be anything like Optimism or Arbitrum, which has negligible gas fees. But yeah, right now it's just Sepolia. So testnet.
Okay, I see. Thank you.
Yeah, I'll also give you some pointers on the marketplace side of things. So once you have your node up and running, you can also interact with the marketplace. But please note that if you do that, you're a lot early, and there are a lot of things breaking down right now. So you might experience errors, but if you wish to contribute, that's a good place to really focus on. But yeah, before we head there, I'll show you the other features available in the testnet. So, in the installer. So you can also upload and download files using the CLI, or you can also use the Codex app, which I will be using right now. So you can hit the fifth option, which should take you to the Codex app, or an alternative could be just to run your node and go to app.codex.storage. This is the same. So you can go over here and you can just give a preferred name. And once you have that, you will see a health check over here, which basically checks if all the requirements are met. So in our case, the internet connection and Codex connection are available because I have a Codex node running. If you don't have a Codex node running, and if you go to app.codex.storage, this should not be checked. It should be incomplete. But since we have the first two steps done, it shows me completed. And the third and fourth steps are for port forwarding and marketplace. So port forwarding requires you to basically forward your ports on a router, like I mentioned over here in the docs. So you can watch YouTube tutorials on how to do port forwarding, but right now I'm on a public network, so I won't be able to do that. But it shouldn't be hard for you to set it up. It should, again, take you like a minute or two. So yeah, port forwarding is another requirement if you want to share files with other people. And finally, the marketplace is still alpha, so there's a lot of things breaking down, but I will show you the marketplace contracts and also the APIs later. But now let's try uploading and downloading the files and generating a CID for a particular file. So to do that, just go to the next step, and then you should see this dashboard in front of you. And right now I don't have a peer connection, but then that's because I don't have the port forwarding set up. But anyways, I can just show you how to upload a file. So you can pretty much select any file. Let me select this particular file. So yeah, this is uploaded. To find the CID, I can go here to files. And in the files, I see the list of all the files that I've uploaded into the testnet. So this is the CID pertaining to the particular file that we uploaded. Just copy the CID. And if you have port forwarding set up, this should potentially help you share files with other peers. So for example, if you are running a Codex node, and if I have port forwarding set up already, I can just share you the CID, and you can go over here and paste it over here in download section and download the file. You also have the download section over here, I guess. Yeah, over here. So let me try downloading this from my local node. But another thing that you have to notice, the file name, this is basically a bug in the front-end application, but then the file name does not automatically get stored over here. So you will have to manually save the file. But once you do that, you'll be able to see the file stored. So in my case, I think that was a PNG. Let me just check. Yeah, it's a PNG. Let me just say downloaded file.png. Now, when I open this, yeah, this is downloaded. So this is a minor bug that needs to be fixed with the interface. But then when you use the CLI, this should automatically download the file with option 6 and 7. This will download the file with the proper file name and the file extension. But yeah, that's pretty much about what Codex is right now till step 7. You can view your local data by going here. This has all the data available in your local node. And if you wish to uninstall Codex, just hit step 9, and this will uninstall Codex from your machine. So that's all about the installer that we have. And finally, if you have any feedback, it's really valuable to us to improve your Codex experience. So hit this 10th option. It will show you a simple form that asks you for your feedback. And that will be really helpful for us in making this experience better. But now that we have a Codex node running, I'll go ahead and show you what are the different other things that you can do with Codex. So when we look at the documentation, we have the first 3 parts completed, also the 4th part completed with uploads and downloads. After you complete this, you have this what's next section where we have the Codex REST APIs that can help you interact with your Codex node. I'll take you through the Codex REST APIs. Firstly, it's available at api.codex.storage. You can go here to see all the list of APIs that you can use for interacting with your local node. So the marketplace section has all the APIs that can be used for interacting with the marketplace contracts. So this is a lot experimental than the other ones. So yeah, let's go ahead with the second section first, data, which has endpoints for basically uploading files in a streaming manner, and also downloading files from the local node and downloading files from the network to the local node. So you have multiple APIs available for this, and it's pretty simple, well documented. The APIs have worked very well for me. So I'm expecting it should work for everyone's. So we also have a note section where you can get the node's peer ID, and also a debug section where you can get the node information. For example, this endpoint should show you all the node information. Yeah, that's all my node information. But yeah, that's pretty much for the API. And Codex has a very new JavaScript library or a TypeScript library. It's pretty new. We don't have much of applications built on top of it. I'll show you the repository for that. It's this one. Yeah. So Codex.js is our first SDK that we have, and we have maybe 1 or 2 applications built using the Codex SDK, and we're also working on making the SDK a lot more better. So you can also use the SDK directly without having to look at the APIs. Yeah, it's all well documented in the README section of the repository. And this is the link to the repository if you want to check it. And now that we are done with that, I'm also going to show you an application that I'm personally building on top of Codex. So it's called share.hackyguru.com. This is a file sharing app that I'm trying to build just as an example for people to understand how Codex and Waku can work together. So I remember mentioning this project called Waku when I was showing you the free.technology portfolio. And Waku is the communications protocol, and Codex is the storage protocol. And we look at Ethereum. I'll just show you an image of the Ethereum white paper itself. Yeah, this is a great image that I can potentially reference. Yeah, so Ethereum as a white paper had Ethereum just for the consensus layer, but to Ethereum to work efficiently, it has some complementary technologies like Swarm and Whisper. So all these 3 technologies together formed Ethereum itself in the Ethereum white paper. So Ethereum is the consensus layer, basically the on-chain layer, and Swarm is the P2P file transfer layer, or the basically what Codex is right now. And there's also other alternatives like IPFS, who do content-based hashing and storage, and also Codex, which provides you with better durability. And there are multiple other DSNs who do this. So this is the storage layer, and Whisper is the communications layer for ephemeral or dynamic communications that you can use. So imagine this to be a network of sockets. That's how I like to explain Waku. So yeah, all these 3 together can help you build a decentralized application. That's how the Ethereum white paper was proposed, and that's how it was meant to be. And Waku is a cool technology. You can learn more about it at waku.org, where you can kind of build a privacy-focused and securely scalable communications infrastructure for your applications. And in this application called FileShare that I'm building right now, I've used Waku along with Codex to create a room-based file sharing. So if both of us are in the same room, like let's say both of us are in XYZ 123 room, or maybe even more, maybe everyone on this call are on the same room, I can basically drag and drop any files over here to share the files with other peers who are connected with me. So that's the intent of this application. I haven't completed it fully, but if you already follow Codex and Waku socials on Twitter, you will be seeing a blog post coming out in the next couple of days after I complete this fully. But yeah, that's how it is supposed to work. You can go here, add your Codex API endpoint, which will be active after you run a Codex node. And you can also configure the Waku settings. So in terms of Waku, if you use a light node configuration, you don't have to do any settings. So yeah, you just have to run a Codex node, come to share.hackyguru.com, and then select any file to share. Let us try sharing maybe the same file. Yeah. So after I select the file, you can see that the file is in my sent files section over here. And when I copy the CID, this should copy the CID. And the best part is, since the file is the same file, the CID won't be duplicated, just like IPFS or any other content-based storage. This makes it makes files immutable as it's content-based. It's hashed content-based, so that way file tampering is not possible for a particular CID. So yeah, that's about the sent files part. And people who are listening to the same room ID will have this file on the received files part. But this is a cool application that you can look at for understanding how to implement Codex in an application perspective using the Codex APIs. And there's also another application that my colleague is building. It's called Kwaku. Kwaku means questions and answers powered by Waku. So this also uses Waku and Codex under the hood. So you can pretty much create question and answer sessions using this. Like, for example, if I want to get a list of Q&As from this particular Google Meet, I can just create a link and share it over there so that people can ask questions using Kwaku, and I can just answer them using this interface. But we do have a problem going on for the last couple of days with Waku. The Waku fleet is going through some updates, so it's kind of not reliable at this moment. So yeah, like I just have 4 Waku peers connected right now. It should work because I have 4 peers connected. But then I think by next week, after the updates are done, this should be a lot more reliable in terms of sharing files. But that's how both these applications are designed to be: Waku for the communications layer and Codex for the storage layer. So basically, what Waku uses over here is the metadata of each and every file that you store on Codex. So the maximum file, message size in a Waku object can be 1 megabyte. So this file can be probably more than a megabyte, maybe like 5 GB. So if I want to share this file, I first store it on Codex, and I share the CID of the file on Waku. So that's how the architecture looks like for communications along with file sharing. So yeah, I will also show you a cool React hook that you can use. This is available in my GitHub. Yeah, it's called Codex Waku example. Again, this is very new, so expect some bugs and errors to pop in every now and then. So when you go into the hooks folder, you will see something called use Waku and use Codex. So these are 2 good hooks that you can use. If you are vibe coding using AI, these both snippets are going to be super useful. So in my case, I'll show you use Codex. So yeah, this is a simple hook that kind of helps you. Oh, it's not over here, but then you can find it on the code base. We have codex.ts probably over here. Yeah, I'm guessing it's over here. So what basically happens is we use api.codex.storage. Over here, we use these endpoints. Yeah, this particular endpoint is for downloading a file, and this is for uploading a file. So let's look at where this particular code is. I have my VS Code open anyway, cursor open anyway. So Yeah, I'm not sure which particular endpoint that I was using, but it should be somewhere with v1 data. Yeah, found it. So this file has all the code that you would require. It's in index.tsx. I haven't put it into use codex.tsx yet, but then it will be done later in the day. But yeah, you can see example snippets of how to store files over here. So this particular endpoint can simply help you upload and download. And it's pretty simple. You can just kind of understand it from one file. But anyways, that's how you can build stuff on top of Codex. And let's go back to the documentation to see if I missed something. Yeah, so that's the REST API part. And we have the marketplace support. So you can run Codex with the local marketplace support by following the instructions over here. You'll just have to run a couple of commands to get your local marketplace set up, and then you can interact with the marketplace contracts. And once you have this set up, that means that you have a completely working piece of, peer-to-peer network along with marketplace that helps node operators, store your files and get incentivized for it. So that's the second thing that you can do after running your Codex node. And finally, you can build the applications using Codex.js library that I showed you earlier. So yeah, I think that's all about Codex for now. If you have any more questions, you can always reach us on Discord, and we'll be happy to help. And if you wish to dive even more technical, you can read the tokenomics light paper, which is right on the left side. Yeah, this gives you a complete overview of how the Codex tokenomics work, how the incentivization structure is different from the other available alternatives in the storage side of Web3. And if you wish to go on a deeper technical overview, you can look at the white paper, which is the holy grail for understanding how Codex works in terms of the decentralized durability engine and stuff. Also, Codex, particularly to state some highlights of how Codex is different from IPFS and Filecoin. Codex uses erasure coding instead of whatever Filecoin uses, like proof of replication, proof of space-time, and all the other things. But Codex uses erasure coding for making sure that the files are redundant in the network, and the files are also not corrupting, and it's automatically repairing even when there's some problems in the network. So that's one difference. And the other differences include things like garbage collection, for example. So in IPFS, if you don't access a file for more than 30 days, the file simply disappears. So imagine you mint an NFT, and after you don't access the NFT for 30 days, the asset is completely gone from IPFS. So that's how non-durable IPFS and Filecoin are. And with Codex, we focus on filling these gaps to make sure that it's a more reliable DSN. Yeah, so that's all about it from me. If you have any questions, I'll be happy to answer them now. Or you can also ask the questions in the Codex Discord, and I'll have my team help you over there.
Hi, Guru. Yeah, very amazing job. Yeah, I have a question. Is that you say that it use erasure code to keep the data durability. Yeah. So you need run many nodes. Yeah. Many nodes, like Ethereum. Ethereum node keep the blob data. So there are many nodes running. So how can you encourage I think you need to encourage enough developers to run the nodes. Yeah, if you want to use erasure code.
Yeah. So to answer this, I see the question has two subsets. The first one is how erasure coding can be implemented, I believe. And for this, I just did a explainer tweet on how erasure coding works. I just sent a link on the messages over here. So that's a very high level overview of how erasure coding works. But yes, for the Codex network itself to evolve and provide better storage, we need a lot of node operators to join Codex and run nodes to offer storage. And yes, the mainnet launch is scheduled later at the end of this year. So right now, most of the things that happen in Codex are pretty new, and we don't have any incentivized testnet as of now. So there is no use of people running and offering storage at this point. But yeah, like once we have the incentivized testnet and the mainnet, I feel like it's going to be really attractive for people who have infrastructure to offer storage. So basically, another explanation could be this consumer side of Codex, where people create the demand for data, and there's the node operator side of Codex, where people store data that is coming from the demand. So the challenge for the Codex team is to grow both of it. Yeah, so only when the consumer demand grows up, the demand for storage operators will grow up. So it's like a proportional growth that we should be looking at.
Thank you. Yeah. I see.
Any other questions?
Do you think if Waku use Codex to build a decentralized communication dApp, is it very expensive for user?
Yeah, so we did sponsor a lot of hackathons with Waku last year. For example, we had 81 projects that were built on top of Waku. I can also share the link to these projects. But basically, the problem that most of the projects had was storage. With Waku, you are not supposed to share big files because it's just a layer for communicating metadata, or like a small JSON object or something that's less than a megabyte. So yeah, the best way to share bigger files is by using Codex as a storage layer, and you just share the metadata on Waku. So example, in this awesome Waku repository that I linked, we have like 85 projects that use Waku. And out of the 85, at least 25 projects needed some kind of storage solution. So that explains that there's still demand for storage.
Oh, anything else? I think that's it.
Cool, guys. Anyways, if you have any questions, again, feel free to join the Codex Discord. Shoot your questions over there. And thanks for having me for today.
Yeah, thanks, Guru. Thanks for your excellent presentation to tell us how it works and how these projects or your ecosystem work together. It's pretty nice. Yeah, thanks for your presentation and all of the audience joining in this presentation. Thanks a lot.
Yeah, thanks, Guru. Can't wait to run it on my computer now. Okay.
Yeah, I'm excited to see your node on the network.
Cool.
Then have a great
cool.
rest of your evening. Bye-bye.
Yeah.
Bye-bye.